Alrighty. Thanks, Yi, for the nice introduction. My name is Ben Waters. I'm the CEO and one of the co-founders of Wibotic. Wibotic is a venture-backed 15-person company based up in Seattle, Washington. And we are focused on wireless charging for robots. And to preface the problem that we solve, there has been a massive transformation in the last 5 years for the robotics industry as a whole. Machine learning, automation, AI, the evolution of sensors have allowed these systems to go from single devices that we all know and have probably used in some cases before to fleets of highly productive autonomous systems with real-world applications that save real costs for businesses and improve efficiencies and worker safety for a lot of different industries. But there's a big problem. Batteries and charging has not received the same level of attention as has the automation of the vehicles. When a human's in the loop, it adds cost and eliminates the efficiencies of these systems. The photo in the upper right is an actual warehouse in the UK that was using a fleet of mobile robotics that burned down because one of their sort of DIY charging stations failed and caused a fire. And for the marine industry, it costs anywhere from $2,000 to $50,000 a day to send out a research team on a vessel to simply deploy and recover these vehicles. So Wibotic is really focusing on solving this power problem for autonomous systems across a variety of different industries. Wibotic works in mobile robotics, aerial drones, industrial automation, and marine vehicles. And the key innovation that we bring to the table in the wireless charging technology is our flexibility. Many of you have probably experienced cell phone wireless charging systems where you have to get the phone very accurately in place of the charging station. But for Wibotic, we afford tens of centimeters of flexibility without degradation to the charging time. And we're focused on a power level that can charge these large batteries on these devices in 1 to 2 hours. We can deliver up to 300 watts of power with our technology that's on the market today. So just as an overview about how this system works, Wibotic sells hardware and software. The hardware piece consists of a transmitter or a charging station that gets distributed throughout a warehouse or built along the seafloor, and a receiver that integrates with the vehicle and does the battery charging. And one of the things that we've learned focusing on this fleet-level charging solution is that charging a bunch of devices is very different in terms of the automation and the learning that those systems go through than charging a single device. You can imagine a warehouse with thousands of robots. Knowing where and when to send those robots to go charging has a major impact on the uptime and therefore the cost of maintaining these systems. And as these vehicles become more prevalent in the marine ecosystem, you can imagine this problem becomes only more expensive if not addressed properly. Marine vehicles are much more expensive to build and deploy, and when operating at depth, you sometimes don't have the means to communicate with them at the surface. So they have to be doing the right things. They have to be charging at a very, very high level of reliability. Wibotic has a lot of traction. We have over 50 total customers across these few industries. I won't spend too much time talking about mobile and aerial today, but I did want to just go into a couple applications for some of the systems we've deployed in the marine space. So this is just a simple photo that kind of shows you how our system works. That yellow cylindrical disc is actually the docking station. And we built it that way so that these small, those are only about 1 meter in length, UUVs, can dock and also maintain a level of mechanical position, even if they're bobbing at the surface. And the company who makes these builds these as a swarm. So they have 50 of these or so in a swarm that can dive to a controlled depth, take measurements, float back up to the surface, dock in one of our charging solutions that floats in a big buoy structure at the surface, and when they're at the surface they can all communicate, and they can just do this completely autonomously. These are being used for some near shore sewage treatment plants, making sure that things aren't leaking out Similarly, in offshore renewable sites and energy sites where there's risk of contamination, these robots are a very low-cost way to have a completely autonomous set of devices that can capture data and provide it to people who are interested. And kind of a different industry is one that is, this device is built by a company called Fred.Olsen. It's a wave energy generating device. Just by sitting out in the water, it can consume up to about 20 kilowatts of power continuously. And what we did, we partnered with Fred Olsen and the University of Washington Applied Physics Lab, and we mounted our charging station on the bottom of this device. And the theory is that any autonomous vehicle or vessel can dock up to this thing and wirelessly charge up through our system, but our system is powered from the wave energy device generating energy. So it's a completely sustaining, completely off-the-grid way of powering up these remote vehicles. And the goal of this project was simply to prove that our system can persist the test of time. We deployed this for 6 months in the warm, balmy waters of Hawaii, and it was subject to lots of biofouling and environmental change over those 6 months, and proved that our system could continuously recharge the battery on a payload for that entire duration. So we're very excited about all that's happening in this space. We're excited to be partnered with Schmidt Marine, making these systems available for enabling low-cost, very persistent monitoring of the ocean. And we are a growing company based up in Seattle. So if you know of any robotic companies or have any interest in learning more about any of these industries, I'd be happy to talk. And we have a demo of our system upstairs after this. Thank you very much.